I'm exploring how increasing the alpha parameter in scikit-learn's RidgeClassifier affects the model's behavior, specifically when dealing with features that are highly correlated, multicollinearity. I'll examine the effect of this change on coefficient magnitudes, multicollinearity impact, bias variance trade-off, and classification accuracy. This is a key concept in understanding regularization. We're using a RidgeClassifier, a type of linear model. The alpha parameter is a hyperparameter that controls the strength of L2 regularization. This is crucial because it helps us control overfitting and improve model generalization. I'll be focusing on how changing this alpha value changes the whole model's behavior. Let's dive in. Here are the possible answers. Each answer relates to the effect of increasing the alpha value. I'll analyze each one carefully to find the right ones. Sounds good? This statement suggests that a larger alpha leads to larger coefficients. However, I know that L2 regularization works by adding a penalty to large coefficients. Therefore, increasing alpha, which increases this penalty, actually shrinks coefficients towards zero. This is an incorrect statement. This is stating that a higher alpha helps reduce the influence of multicollinearity. I understand that multicollinearity can create unstable coefficient estimates in linear models. Regularization stabilizes these estimates. A larger alpha strengthens this stabilization, reducing multicollinearity's negative effects. This looks correct. This says increasing alpha increases bias but reduces variance. I remember that bias represents how far our model's prediction is from the true value on average. Variance reflects how sensitive the model is to different training datasets. Increasing alpha simplifies the model, higher bias, but it becomes less sensitive to training data fluctuations, lower variance. This makes sense, therefore, it's also correct. I see this statement as wrong. Increasing alpha in RidgeClassifier actually does the opposite. It shrinks the coefficients towards zero. Think of alpha as a dial controlling the penalty for large coefficients. A higher alpha means a larger penalty, pushing those coefficients down. This is correct. Multicollinearity is when your features are super-related. This can cause problems because small data changes wildly affect coefficient estimates. Alpha helps here. By shrinking coefficients, it stabilizes these estimates, making your model more robust. This refers to how we change alpha. We increase it gradually. Absolutely right. Increasing alpha simplifies the model, which means more bias. But it also makes it less sensitive to training data quirks, which means less variance. It's a trade-off you need to balance. I see this as wrong. While regularization often helps, too much regularization, a very large alpha, can lead to underfitting. And this will actually hurt accuracy. You need to find the sweet spot. This is the title of the quiz question. We're exploring how changing the alpha parameter in a RidgeClassifier affects the model's behavior. It's all about regularization. This is the core question. We need to determine which statements correctly describe what happens when you increase the alpha value in the scikit-learn's RidgeClassifier. I'll say this is false. Increasing alpha actually makes the coefficients smaller, shrinking them towards zero. Think of it like this: a larger penalty discourages big coefficients. This is true. Multicollinearity is when your features are highly correlated. A larger alpha helps stabilize the coefficients, making the model less sensitive to these correlations, thereby reducing the negative effects of multicollinearity. This one's also true. Increasing alpha simplifies the model, increasing bias, the model's error from making assumptions. However, it reduces the variance, how much the model's predictions change with different training data. It's a trade-off. Nope, this is false. While regularization often helps, too much regularization, a very large alpha, can lead to underfitting, where the model is too simple and doesn't capture the data's complexity well enough, resulting in poor accuracy. I'm using scikit-learn's RidgeClassifier, a linear model that uses L2 regularization. The alpha hyperparameter controls the strength of this regularization. A larger alpha means stronger regularization. Increasing alpha directly shrinks the coefficients towards zero. Imagine it like tightening a spring. The higher the alpha, the more the spring pulls the coefficients closer to zero, reducing their overall magnitude. With high multicollinearity, features are strongly related. Increasing alpha stabilizes coefficient estimates, reducing the instability caused by this strong correlation. It's like adding a dampener to a noisy system. Increasing alpha increases the model's bias, making it simpler and potentially missing some details from the data, but decreases its variance, making it less sensitive to the training data's noise. It's a classic trade-off, finding a balance between a simpler, less flexible model and a more complex, potentially overfitting one. We're exploring the RidgeClassifier, a machine learning algorithm. A key part of this algorithm is the alpha hyperparameter, which controls something called regularization. Think of regularization as a tool to prevent overfitting, where your model learns the training data too well and performs poorly on unseen data. This question focuses on understanding how changing the alpha value impacts the model's performance. We'll be evaluating the different effects on model coefficients, multicollinearity, and bias variance trade-off. Increasing alpha helps to mitigate the effects of multicollinearity. Multicollinearity happens when your features, the variables predicting the outcome, are highly correlated. This can cause instability in the model's coefficient estimates. Regularization, controlled by alpha, stabilizes these estimates, making the model more robust. I think of it like this. Imagine trying to balance on a tightrope. High multicollinearity makes it really unstable. Regularization acts like a steadying hand, improving balance and stability. Increasing alpha strengthens regularization, making the model simpler. This increases the bias because we're making the model more rigid. It might not fit the data as closely. However, it also decreases the variance, which means the model becomes less sensitive to changes in the training data. It's a trade-off. We lose some accuracy in fitting the data, but gain stability. I would compare it to the difference between a very specific set of instructions, high variance, low bias, and a general guideline, low variance, high bias. The general guideline is simpler but less precise. I disagree with this. Actually, increasing alpha does the opposite. It shrinks the coefficients, pushing them closer to zero. Remember, the regularization penalty in RidgeClassifier is proportional to the square of the coefficient magnitudes. A larger alpha makes this penalty stronger, forcing the coefficients to be smaller. This statement isn't always true. While regularization often improves generalization, the model's ability to perform on unseen data, making alpha excessively large, can lead to underfitting. The model becomes too simple and cannot capture the underlying patterns in the data, thus reducing its accuracy. It's like trying to fit a straight line to a curved relationship. You'll lose out on accuracy. I see this as the core concept. We're focusing on the RidgeClassifier, a type of linear model in machine learning. The crucial element here is the ALPHA parameter, which controls regularization strength. Regularization helps prevent overfitting by penalizing large coefficients in the model. This is key to understanding the behavior of the model and how the parameter affects its predictions. This question probes your understanding of how increasing the ALPHA parameter impacts the RidgeClassifier. It's not just about memorizing formulas, but truly grasping the effect on model behavior and, crucially, how it tackles multicollinearity. The final result of the RidgeClassifier is the classification output. This is what we ultimately care about: how well the model classifies data points. This output is directly affected by the ALPHA parameter, as it influences how the coefficients are calculated and, consequently, the model's predictions. This step is where the magic of ALPHA happens. As ALPHA increases, the model's coefficients are shrunk, or reduced in magnitude, towards zero. It's a crucial step to understand, since we are directly examining how regularization impacts the model's complexity. Before feeding data into the RidgeClassifier, it's often essential to scale features. This ensures that features with larger values don't disproportionately influence the model. While not directly related to ALPHA, it's a crucial pre-processing step to ensure fair comparison. The data we feed into the model. The quality of this data, its relevance, accuracy, and characteristics such as multicollinearity, heavily influences the model's performance. Remember, ALPHA parameter helps deal with multicollinearity problems of this input data. A visual representation would be super helpful. This diagram is important because it should show how increasing ALPHA affects the decision boundary or the coefficients of your model in a visual way. The diagram would solidify your understanding and help to visualize how regularization affects model behavior. I'm talking about a RidgeClassifier, a machine learning model that uses a technique called L2 regularization to make predictions. Think of it as a smart way to balance accuracy and simplicity. We're looking at what happens when you increase alpha, a crucial parameter in the RidgeClassifier. Alpha controls how strongly the model applies this regularization. Increasing it means we're telling the model to be less complex. This statement is incorrect. Increasing alpha actually does the opposite. It makes the model's coefficients smaller, effectively shrinking them toward zero. I see it as putting the brakes on overly large coefficients. Incorrect. While increasing alpha usually helps avoid overfitting, a situation where the model performs well on training data but poorly on new data, it's possible to go too far. If you make alpha too big, you could end up with underfitting, where the model is too simple to capture the patterns in the data correctly and accuracy suffers. This is correct. This is a key concept in machine learning. By increasing alpha and simplifying the model, you are increasing its bias, or tendency to make certain types of errors. However, you are simultaneously decreasing the variance, meaning the model becomes less sensitive to the quirks of a specific training set. In a nutshell, changing alpha affects how much the RidgeClassifier considers the complexity of the model versus the data. A larger alpha leads to a simpler, more biased but less variable model. This one is also true. Multicollinearity is when features in your data are too closely related, which can mess with the model's coefficients. By increasing alpha, I'm essentially stabilizing those coefficients and making the model less sensitive to this issue. Makes sense? This is the question this entire explanation is addressing. I think I've covered all the key points.